Hello, welcome again. We are solving GATE 2016 Aerospace Engineering paper. Question number 9 is consider an eigenvalue problem given Ax is equal to lambda I x. If lambda 1 represent the eigenvalues of non-singular square matrix A, then what will be the eigenvalue of matrix A square? So option A lambda I 4, option B lambda y square, option C lambda I 1 by 2, option D lambda I 1 by 4. So if lambda is the eigenvalue of the matrix A, then lambda raised power n will be the eigenvalue of matrix A raised power n. So answer is option B. Next, question number 10. If A and B are both non-singular n into n matrix, then which of the following statement is not true? Not det represent determinant of the matrix. Option A d bracket A into B is equal to d A determinant A into determinant B. Option B determinant A plus B is equal to determinant A plus determinant B. Option C determinant A minus A minus A inverse is equal to 1. Option D determinant A raised power T 8 force is equal to determinant A. So answer is option B. So that is the formula that you have to remember. You can prove it by taking different matrix, two different matrix, and finding out and then summing these up and then finding out the individual determinants and verify this properly. Okay. Next, question number 11. The total number of material constants that are necessary and sufficient to describe the three-dimensional Hooke's law for an isotropic material is. So for an isotropic material, the properties of the material is same in all the three directions. If so, for to determine longitudinal strain, E is required, and in the other direction, if you want to determine strain, then mu or G is required. So number of constants are two. Either one of them can serve our purpose. So E or mu or E and mu or E or E and G may be required. So total number of constants required are two. Next, determine the correctness or otherwise of the following statement A and R. Option A, in a plane stress problem, the shear strain along the thickness direction of a body are 0, but the normal strain along the thickness is not 0. R reason, in a plane stress problem, Poisson's effect induces the normal strain along the thickness direction of A. Option A, both A and R are true and R is the correct reason for A. Option B, both A and R are true but R is not the correct reason for A. Option C, both A and R are false. Option D, A is true but R is false. So answer is option A because this is the correct explanation of this statement. Both statements are true because in a plane stress problem there is stress in two directions, and due to these stresses there is strain in third direction also. Okay, so uh, the strain in thickness direction is the strain in thickness direction is not 0, but the shear strain is always 0 in third direction. Okay, so normal strain along thickness is not 0, and because it is due to that lateral strain, and so and lateral strain is due to Poisson effect. Okay, so this is correct, and this is the correct explanation of statement A also. So explanation is, in a plane stress problem there exists a lateral strain in that direction, so but no shear strain. Okay. So next, consider four thin wall beams of different open cross section as shown in the figure. As shown in the cases 1 to 4, a shear force of magnitude F acts vertically downward at location P in all the beams. In which of the following does the surface does the shear force induce bending and twisting? So this is the case 1, this is case 2, this is point P, F is force is acting, this is point P, F force is acting, and this is the thin wall section is like a channel section, and this is also we have the P is this point and F is acting at this point. Here the force F is acting at this point and P is this point. So options are A1, 1, B2, C3, D4. So uh, in case 1, the that force is acting at some distance from the center of these two. Okay, so this is not acting at the center and this is not a symmetrical section. So it will induce the twisting as because and so this is not the shear center of the thin thin channel. So as this is not the shear center, so it will produce twisting as well as bending. So but here this is the shear center of that channel section or centroid of this channel section. Uh, so this will not include any twisting. Here this is also the centroid of the section, so this will not be twisting. So this will also not introduce twisting because this is also center or shear center. So answer is option 1 because this is not the shear center. When the shear force is acting at the shear center, then it will not produce any twisting, but this is acting at somewhere at a distance from the shear center. So answer is option A. Okay, so answer is option A. In case 2, the P is the this is the shear center. In case 2, 3 and 4, P are the shear centers of this figure respectively, but this is not the shear center, so that's why it will produce twisting. So answer is and as well as bending. So answer is option A. Next, the effective stiffness of spring mass system as shown in figure below is 4 kilonewton per meter, 2 newton per 4 newton per mm, 2 newton per mm, 2 newton per mm. So these springs are in series, so their equivalent stiffness will be 1 by k1, 1 by k2 plus 1 by k3, and this is in parallel with this. So total stiffness will be 4 plus 1 by 1 by 2 plus 1 by 2, that is 5. So k equivalent is 5 newton per mm. Okay, so answer is 5. Question number 15. A structural member supports loads which produce at a particular point a state of pure shear stress of 50 Newton per mm square. At what angle are principal planes oriented with respect to the plane of pure shear? So structural member supports load. So this is your structural member and it is subject to the pure shear. So and it is subject to the pure shear.